Hello everyone. So now our today's topic in this video is the laws of exponents. Today we'll discuss about our new chapter exponents and its laws. Let's just start. So you all know now what is the exponential form. Here you can see 5 raised to power 3. That means here the 5 is base and 3 is our power or exponent you can say. So you all know about this, how we can write the exponential form. So 5 is called base and 3 is called exponent. So what does it indicate? The 5 raised to power 3 indicate that 5 is multiplying 3 times. That is you all know. So where we use the laws? See the next example. 3 raised to power 4, which means 3 is multiplying 4 times, which is equal to 81. So here you all know that exponent means what? The shortcut of or the short method to write the multiplication, then only we will write 3 raised to power 4. So where we apply the laws? So applying laws means that solving the exponents using the operations. We apply these laws, we need these laws where we use operations like multiplication or division for solving the exponents. Let's just see. We have some 5 laws, the basic 5 laws here, which is used in different operations. The first one is multiplying, the second is dividing, the third is power to a power, the fourth is 0 power, and the fifth one is the negative exponents. So these are some 5 basic laws which you will use to solve the exponents. So let's just start one by one. The first one is the multiplying exponent law. So what is it? If you are multiplying exponent with the same base and keep the base and add the exponent, then it is called the multiplying exponent law. What does it mean? That when a number is multiplying with different powers, the powers will be added. See, x raised to power m multiply x raised to power n equals to x power will be added, m plus n. Which means then when we have the same basis but with different powers, the power will be added. You can see one example on the board. 2 raised to power 6 multiply 2 raised to power 3 will be equal to 2 raised to power 6 plus 3. That means when the bases are same, the powers will be added, but the bases must be with multiplying. So the answer will be 2 raised to power 9, and then you can solve it, multiply it 9 times and you will get 512, right? So this is how you will use the first law when you see there are same bases, they are in multiply and different powers, so you will add them. So now you can solve these questions based on the first law. You can see there are multiplying, but in a different way it is written. First one, the multiply sign, the second one bracket sign, and the third one with the dot. So you can try these. Next is dividing exponent. In dividing exponent, the same thing, the same basis will be now dividing, but with different powers. So how we will solve it? Using the law. See the law. When the dividing exponents with the same base, keep the base same and subtract the exponents. So this is the dividing exponent law where the same numbers are dividing with a different base, then the powers will be subtracted. So see the example for this. 2 raised to power 6 divided 2 raised to power 2. So here they are in dividing, so the powers will be minus. Earlier you have added the powers, it will give you 9, but here you are subtracting because the numbers are in divide. So here you will get 6 minus 2, 2 raised to power 4, and it will be equal to 16. So this is the second law. Now next, raising a power to a power. You can see the example. What does it mean? Power to power means you can see the 2 powers. 2 raised to power 3, then bracket, then again a power, means power to a power. So how we can solve it? We have a law for that. See, power to a power. If you are raising a power to a power, you will multiply the exponents. So it means when there are power under the bracket and outside a bracket, you will multiply it. So x raised to power m bracket n So it will be multiplied m multiply n and it will become xmn. See the example on the board, 5 raised to power 3 bracket power 2. So now how we can solve it? We will multiply 3 with 2. So 5 raised to power 3 multiply 2 will become 5 raised to power 5. Now the next is 0 power. 0 power means what? When the power is 0, so here 4 raised to power 6 upon 4 raised to power 6. So these kinds of example are of 0 power. See the 0 law of exponent, what it says. Any base powered by 0 exponents equals to 1. So whenever you can see the power is 0, it will be equal to 1, because in these examples you will see that 4 raised to power 6 upon 4 raised to power 6, the 6 and 6 will be minus and it will give you 0. And same for the another one, 8 raised to power 9 upon 8 raised to power 9 will also give you 0. So when you give when it give you 0, then it will equal to 1. So whenever you will see a power 0, it will be equal to 1. You can see some examples on the board. If it is written like this, you will be write equal to 1. Now the last one is the negative exponents. So negative exponents, you all know, that means a power in negative sign. So how we will solve it? If the base is powered by negative exponent, then the base become reciprocal with the positive exponent. So how will we solve it in the negative exponent? X minus m will be equal to 1 upon x power positive m. It will be positive and then you can solve it. See the example on the board, 5 raised to power minus 3 will be equal to 1 upon 5 raised to power 3, and then we can solve it. 5 raised to power 3 will be equal to 125, so we can write it 1 upon 125. And another one, 1 upon 3 raised to power minus 2 will be equal to 3 raised to power 2 and it will be equal to 9. So this is how we can convert minus exponent into the positive one. We can change like this when we will reciprocal it. So this is it. This is how we will use these 5 exponent, these 5 basic exponent in different type of questions. So thank you all. I hope this will help you out, and for more queries we will discuss in class.